So you can take a look on it after. Yeah, so basically it was the question about this particular method, public abstract void calculate array. So this is defined as void, and I assume here is the type of mistake. It should be double, not void. Yes, so since we calculate array, it returns the value, so it should normally then return the value. Yeah. So yeah, so when you implement this, I think we can briefly change it to double instead of void, because like if we calculate something, then we expect the result normally. Yeah, I mean, on the other hand, you can create a new method, for example, and then get the values from there, but I think there's no reason. You can simply then define it as double instead of void. So this is one point about activity 6. Okay, so if there are no questions, maybe there are questions you can ask. If not, then we can continue. So last time we talked about some other utilities namespace we have in C#. Wait a moment, just larger screen. We talked about the reflection namespace, which allows us to get the information about methods, about the objects, classes we have, and using it we can do, as I showed you last time, we can do the dynamic method code. So basically it means that we can simply just use the object as the object and call the methods without calling them directly from the variables. Yeah, we can use invoke methods. Yeah, so we can use invoke to call the method dynamically. Yeah, we need to get the method as the object. So when we get the method as the object, we can use it to call it. Yeah, so basically we can skip using the date type, and so we can simply declare the variable as object and do all the stuff needed using this object variable then without casting it to the type. And this may be needed when we have some kind of design of the solution where the classes are not linked to each other, and then we want to call them. But yeah, so I see Maria joined. Yeah, there was Maria asked about this particular method, and so yeah, I think here we can change void to double, since it would be more correct, I think, because void returns nothing. It means that we do not expect any return from calculatory method, and then we can, then instead of using void for calculatory, you can use double to return the value then. So it's just a small point about activity 6. So yeah, let's go back to the reflection namespace. So yeah, the idea would be here that we have some unrelated classes, and they're not related using the object-oriented programming, and not related using the abstraction. They just simply have the same methods with the same patterns, so we can call these methods dynamically without knowing which particular class or which particular design we are actually using. So this is also the part, I would say this is also the part of the abstraction which deals with unrelated classes, unrelated objects. because previously when we used the abstract classes, when we used the interfaces, and when we used inheritance, then we had to know at least date type what to use. I mean, normally it's the superclass or the interface we can use to call the necessary methods, and or to access necessary members of the objects. In this case, when we use invoke, then we basically do it dynamically without, I mean, the method itself does not know the type, it just simply knows that it just simply knows the name and the type of the method, and name and the type of the variable class member used, but it does not know the exact type and the exact hierarchy of the object used. Okay. So basically, we know the method. I mean, yeah, we know the method, or we know the member of the object. Then we can use, we can access this member, or we can call the method. Yeah, but like you see in this case, we don't know what is the type of this value. Yeah, it is not mentioned here. So this is then the option how we can do it, how we can use it, and yeah. So then we talked about input-output namespace. So basically, using input-output, we can read and write in the files. We mostly, not mostly, yeah. So basically, at the base, we work with the text files. Yeah, so input-output maybe it's not the best one to use. I mean, to write in the file, you definitely need to write it to access the stream and to read it. But I mean, like for it's not. It won't be possible using system input-output. It won't be possible to for example, to change Excel file or PDF. Yeah, so to be able to edit such kind of files, you would require more advanced technologies. Input-output is mostly for the text files, and CSV, for example, is also the text file. I mean, it's based on the text. It does not need any encoding. Does not need any special readers. Yeah, so you can just simply read it as and write it as text file. I mean, CSV, XML, JSON files, and similar file format can be considered as text. Yeah. So, and using system input-output, we can read the directories, we can create and read the files, we can edit them, and we can also delete them if needed. And so, yeah, we had some examples in the file paths. We created the files, we read them, and yeah, as the let's say advanced option for the performance and also for the managing of the memory, we better use buffer stream if we want to write the data into the file, not just simply at once, like we have the string, which basically is the file, which is the file content. Then we write it. That would be the easy option. But if we have the case when we need to actually construct the text and we want to add this text into the file and just to do it directly, then you need to use the buffered stream, which makes this approach more efficient from the performance and memory point of view. So these are the main points we had last time. Do you have any questions about what we did on Saturday? Okay, if no questions, then we can move to the current topic, and yeah, we'll continue, and yeah, basically we'll finish with the core utilities we have, and in this particular topic we will talk about the most about the collections. And you already done some exercises using the collections, so now we will recap it and maybe go deeper. So first of all, when we talk about most of the collections, we use generics. So generics, these are just the date types. Date types we can apply to the classes, to our classes, and then we simply use this type for when we actually, at the moment when we use these classes, then we declare these types, these T types. So basically it means that we declare type T inside the class, at the top of the class, and then this T type can be used inside this class, inside the methods this class has. Yeah, and the point is that, like, if the T type is declared, then it should be the same inside the class, inside all the places where it is used. Yeah, like we have one method, type T is used, then we have another method, type T is used in both these methods, then T should have the same type. Yeah, this is basically the point. And for one exact object, yeah, I mean, when we create the object, like we have here, we provide the type. Yeah, so here we say the type is int. So it means that for this particular object, in all the places where T is used as type, it's for this particular object, it is integer. For this particular object, which is created as string, it will always be string. So basically the idea is that template type is changing object by object. So let's have a quick look on it. So as usual, I will create a new solution, so a new project, and I'll add it to the existing solution. So that we can know 1911, and I will add it to the current business solution. Yeah. Okay. So here we go, and let's define the class. I'll use the same file, and then let's say I want to create a class. Let's say I just simply define it as my class. I define type T. Then I have the class, and I declare the type T. So it means that this is the type. I don't know at this moment. Yeah, at this moment I don't know what this type is, how it should look like, but I can use it inside my method. So for example, as an option, I can declare simple member of the class. That would be public T, let's say my member, and then I generate getter and setter for it. So generate getter and setter for it. And yeah, then it means that this particular member has type T. So it simply means that I can create this my class object. So let's say I create it. I provide the type. I create this. Type I provide. So here I cannot provide T. So since T is a template type, so when the object is created, at the moment when we create the object, then the type should be real. Yeah? It should not be just some kind of unknown type T. It should be a real type at this point. So let's say that the type is string, for example, and then I can create the object with the type string. So at this point we fixed this particular type and for this particular object. So for this object, like now all the methods, all the actions we do, we should know that T is string for object. Yeah? So it means that if I want to set the value, then the value should be string. Yeah. So I cannot set the integer. Impossible, since the type for object variable is string. Yeah. So that's why this is not correct. And then we can do it. And for all the other types, we cannot do it. Yeah. So the same is for the getter. Yeah, the getter should be, yeah. For example, for the getter, let's say that I create new variable, and then I can get my member. So maybe I can say here that here we call setter. Setter is called, and here the getter to be called. And the same as for the setter. For the getter, I can only assign to the string. I cannot assign this member to an integer or any other type. Yeah. Yeah. So this is the point. And let's say we have the opposite variant, which is integers. So the same way as for the string, I can create the object for which t type now is integer. Yeah. So when I say for object I, t type is integer. Yeah. So again, now it is fixed as integer and can be changed for object I. Yeah. So the same as for string, I can assign the integer value, and I can't assign, object I, of course, and I can't assign the string. Impossible. Yeah, so this is the key point. At the moment when the object is created, now the t type is fixed. Yeah, so the type is known when the object is created. However, the type is not known when we are inside the class. Yeah. So and like same case you had with the arrays. So remember that you declared the arrays. We can also declare the arrays using this type t. Basically, type t can be used as any other type, but remember that from this particular class we only know that this is the type. I mean, we don't know at this point if it is the string, if it's the integer, or any other type. We only know that this is the type t declared. It should be the same, but no other information is given about this type. So we only know that this is the type, which means that it is some kind of object. Yeah. So here we don't have any information, so it means that I can, maybe let's declare the array. Now declare it as private. Maybe. Yeah, and then let's say I can use indexer. Public, let's say it. So, and here I can getter. Here I can create getter and setter. And same for the setter. Yeah, maybe I'll skip check here for checking the index is correct or not. Maybe I'll skip it now. But yeah, this is the point. Here again, we have the type T. The only information, basically, you can see what is the information we know. We know that we have this type T. We know that my member has the type T. We know that my array is the array of the objects with the type T. And so, yeah, basically we can get corresponding element from the array and we can set the element. Basically, no other information is known. For example, let's say I have methods. So, and let's say if I access the elements, this is my member. So at this point, I only know that this is the object. So it means that I cannot assign string. Yeah, I cannot assign string. I cannot assign integer. I have I have no information about this particular object. Yeah, so it means that at this point the type is unknown. So it's obviously then for random object you cannot assign random value. Yeah, it is not possible. It is not possible. So as an option, again, yeah, the casting also does not work here. Yeah, because again the type is not known, and if the type is not known, then the casting cannot be cannot be done as well. Maybe let's one moment. Let's try one thing. So let's try one thing. And yeah, and then we can try the following. So using the following trick, you can actually assign the any type. Basically, I can assign any try. Yeah, not you can, but you can try to assign any possible type, any type you want to T type. Yeah, so maybe say this is the trick how you can assign any value to try to assign. You can try to assign any value to the variable defined as T. Yeah, I mean, if I want to assign string, I can assign string here. Yeah, I can assign string here. So this would be just the trick how you can do it. But I mean, of course, in this case, I don't know what the type T is. So let's say if the type is integer, then you'll see that we will get the exception. Yeah, let's try. Let's try for example, for string. Let's say that I call object methods, my methods. Yeah, so this should not raise any exception. And for this one, cast will fail. So let's run the program. Can't run for some reason, not sure why. Let's try again. Let's get those. Okay, build is successful. Can I run it? go to, where is run button? Okay, yeah. I just press set up as a starter project. Okay, so let's run, and you'll see that now we get the exception. We should now get the exception. Yeah, you see that at this particular point, when we call the method from integer, we get this exception. We don't get it for string. Yeah, I mean, if we define the type t for string, or sorry, if we define string, sorry, if we define string as t, then we don't get the exception. Yeah, because here it means it will assign string to object. This is correct, and then it casts object, which is string, to type t. T at this point is string, so and my member is t, so I can assign string to string. This would be correct. Yeah, but on the other hand, if I have the type t as integer, so here I assign my string to object, then I try to assign string, then I try to cast string to integer. String cannot be casted to integer, so we get cast exception here. Yeah. So this is the point about t. In t, which is simply defined as type. So it means that I can not use, let's say, my member directly. I cannot call the string related methods or member. So I only can call the methods I have under the moments. I need to cast it. Oh no, I don't need. Yeah, I don't even need to cast it here. But oh no, I need. Sorry, yeah, that's obviously. Yeah, it's correct. I need to cast it here because I cast object to unknown type. So yeah, I need to cast it. Yeah. So and for my member, I can only call the methods which are defined for inside the object class. Yeah, I cannot call string specific methods or integer specific methods. Only the methods from the object class. Yeah. So this is the point. Do you have any questions? Okay. No questions. Hope it's clear. All right. So this is the first point. So then this is how we define it. And maybe one more thing before we continue, we can actually so let me just clarify about the syntax. I forgot about it. One moment. One moment. Yeah. So at this point, as I said, we do not know what are the characteristics of these. So for us, it's just simply an object. Yeah, an object we don't have any information about. But let's say we can assign some characteristics to it. For example, we can say we can use where. Then we can say where t, and then we can say what the t does. So let's say that t is comparable. So let's say that t is comparable. Let's say t is comparable to t. Yeah. So in this case, I actually provide more information to the type t. Yeah, at this point I know that the t can be compared to t. Yeah, so I mean any variable defined as t, we can compare it to any other variable defined as t. Yeah, so in this particular case, I can call the methods public void say say compare to, for example. So here I have t one argument, I have t another argument. So at this point I know, yeah, so here I have this information, I have additional information. I know that type T is comparable. So it means that I can compare variable defined as T. So, and at this point, oh no, so it should be integer. So at this point I can return element 1. So if I try to call the method, you see that I have one additional method, yeah, which comes from the interface iComparable, yeah, and then I can call this method. Okay. I can call this method and compare it to another argument, and this would be correct. Yeah, so I provide this information here. Again, I say that T is the type which can be compared to the variables. This type can be compared to another variable. This type, if I say that it can be compared to strings, for example, then this will not work. Yeah, I need to have the string to compare it. Yeah. So yeah, I can compare the objects which have different type. This is also possible, and actually I can have such option. This would also be relevant, which means that okay, what's going on? Oh no, that's caused it. Yeah, so I can have such situation. I mean, this is not only about the type T, it is about all the types which implement interface iComparable. Basically, the case is that if we implement the interface which has generic type, like iComparable, it uses the generic type, yeah, and it in this particular case it means that we provide the object type we can compare the type T with. So I say that T is comparable to string, and I also say that T is comparable to another T. So we can actually implement multiple we can implement the same interface which uses which uses different generic types. Yeah, so basically in this case we can consider these two. Yeah, basically if we have type T, we can say that let's say my class with the type integer is a different class comparing to my class which has type T string. So basically we create the pattern of the class which may actually then be defined using which can then actually can be used using different types. Yeah, we define this type as T and then use it in different ways. So here I have the error because I say that T should be comparable to string and T should be comparable to type T. Basically the problem is that integer is not comparable to string, and that's why it triggers the error. So maybe I will comment out this. Maybe I'll delete it. Yeah. Now it should be correct. And yeah, so here I still cannot then here then I cannot compare T to strings, so then I skip this. Yeah, so this is the point. So using where I can add additional characteristics to this particular type T. Right? Do you have any questions about it? Okay, so hope it's understandable for you. If not, then let me know. Okay, so once it is done, then we go to the next topic. The next topic is the iterators. So basically, what the iterators are. Yeah, so let's say we have the arrays. So we all know how to go through the arrays. We need to have some kind of index. We want to access the corresponding element from the array. Yeah, so the index can be 0, 1, 2, 3, and so on. So we can use this index to access the element then. On the other hand, we also have the option, as an alternative option, to use for each. Yeah, and basically what happens for each directory iterates through all the elements. Yeah, goes through all the elements and then gets the value of each element. So yeah, and basically in this case, for each it's actually used as the iterator. So we go through all the elements, and this is for the arrays. This is for the arrays, but let's say that we want to implement yeah, we already know partially know how to implement the class as the array, so we can use indexers, as you know, and then using the indexers we can simply use the class, the object as the array. Yeah, we can access the elements from the array. But previously we see that we cannot use for each in such cases. Yeah, so this would be the point, and then let's try to implement such thing. So we have the array here. We know how to access the element from this array using this indexer. But let's say we want to iterate through the elements. And to do this, first we need to implement interface enumerable. Oh yeah, we need to use collections generic. Okay, one moment, let's collections enumerable. Yeah, we need to use collections, and then yeah, that will be it. Okay, so in this case, yeah, that will be correct. No, not enumerable. So that's okay, one moment. Because we support simple tree. Oh, yeah, okay. Oh yeah, I need to implement these. Okay, so this is fine. Now I need to implement this enumerable interface. So then I need to implement the following methods. First of all, I need to implement method get enumerator. Moment, yeah. I need to implement the method get enumerator. This will return me get enumerator. This will be the method, and this will actually then here I can implement the iteration what I want to do. So that will be for each. Then that would be I return br, and that would be then the variable. So that would be elements. So let's say in this, and then I get my array, and then I use yield. So this will turn the corresponding elements. Yeah. So then I return the elements, and at the end I use yield break. Okay, and this is now fixed. Yes, so basically what happens at this point? At this point, let's say that I assign some elements. The object, let's say, O equals element 1, and object. One moment. Oh no, I need to. Oh yeah, I need to initialize the array. Sorry, I thought I can initialize the array. So at this point, the array is not initialized, so it will not work. So let's say I have the array size, and I create the array at this point. And so otherwise, the array is not initialized, so it will be empty object, no object, and it will trigger the errors. Yeah, I need to divide the array size, so let's say we have 10 elements. If we have 10 elements, and maybe I will use only 3 of them. Let's try to iterate through these elements. Because let's say that we do the first. Okay, that'll be fine. So let's try to iterate through these elements. So here I can iterate in var element first. So my element. The type user is the variable, and so the element here can be any you want. So then I want to go through all the object elements, and then let's say that I print these elements. Okay. Let's run the program. Now it will trigger the exception we had before. Maybe we'll, yeah, this will trigger the exception. So let's remove it. Yeah, so basically to simply solve such issue, I can firstly ask if object is if t is string. I can also ask this question, and only after that I can do the casting. So that, as you know, this would be the best approach to check before you do the casting. Let's say not t, but my member, let's say yeah, before you do the casting, it is always better to check if the object you want to cast to, the variable you want to cast to, if it has the type you need. And so the type is string, you can check it and then be sure that this will work. So and then at this point, cast will not fail. And cast is checked, so it will not fail. But it will not assign the value. Yeah. So let's run. Yeah, and you see that the elements are printed as expected. Yeah, so basically using the iterator I can iterate through the elements. Yeah, through the elements, and then again we use, in this case we use the object variable as the array, which is then implemented using our custom class. Right? So do you have any questions about iterators here? Yeah, so using them we can iterate through our object, yeah, in the way as we implement here. So basically we use yield to return the elements. Yeah, so again it goes through and yield returns the elements we provide. Okay. So if there are no questions, maybe let's have 5 minutes, 3 minutes break, 5 minutes break, and I will be back and we continue. Okay, I'm back and let's continue. So in case you have any questions, you can briefly ask them and we can move on. Yeah, basically now let's move on to the collections. So mostly the indexers and the iterators, they are used for the collections. Yeah, so basically they help us implementing the collection classes. Not only us, but they are generically also created, and then we can implement them. For example, not all the. So here we have the indexers as the arrays, and previously we used the arrays to access the index. But let's say we have linked list. I mean, we implement our array, sorry, our collection as linked list. So remember what the linked list means. It means that the previous object is linked to the next one. Maybe let's talk about linked lists a little bit later. Maybe first of all, let's start with the collections again. Yeah, basically collections, we can also call them as containers. So basically container, in programming we have such term container. Not sure if it's used in other areas, not in program. I mean, of course we have containers as physical containers where we can place some stuff. In programming, we usually call the containers as the place where we simply, we can put all the necessary stuff we want. For example, there can be some, let's say, as a simple example, we have the email received in the system. So then the program processes the email, and inside a containers may store the necessary information about the emails, like the sender, receiver, CC, elements, and maybe some technical details about the emails. They can be stored, and about the email, they can be stored in the container. Yeah, and basically container means just simply the place where we place the stuff. Yeah, and then basically we put them inside, and let's say we encapsulate them. Yeah, we close them inside this object, and now they are the part of the object then. Yeah, part of the container. So, and then any type of object can be stored, retrieved, and manipulated as elements of collections. Yeah, so means that we have the container, we have the place where we store the object, and then we work with them as with the elements of the collection. Yeah. So they typically represent the data items that form a natural group. So, for example, usually it's like in when we talk about, yeah, I would say there are the differences between the terms collection and container, because for container we usually assume that the types of the elements are, I would say, the same, and for container the types of the elements are different usually, and like we simply put everything what we can inside the container, and that's it. Yeah, so all the types we want, just put everything inside container. It's just like, let's say, maybe not really garbage, but garbage basket, but the place where we can put everything. This is about the collections, but for the this is about the containers. But for the collections, we usually assume that the elements have the same type. Yeah, so means that like if we have the box of candies, that would be the collection of candies. Yeah, so all the elements are candies. We cannot put something else there. Yeah, we can only put the candies. Or let's say the box of chocolate, then we can only put chocolate inside them, and so on. Yeah, the box of toys, we can only put the toys there, and we cannot put food or anything else there. So type for the collection, type of all the elements there should be the same. Yeah, that's why we basically use generic type. We say that the type of the elements, yeah, generic types are mostly used for the collections, and then they are used to provide the information to the object. Then all the elements the object will have, they all are the same, and at the moment when we create the object, we define the type of these elements. Yeah. So yeah, this is what the collections are. Do you have any questions about general definition of the collections? Yeah, so the object which stores the element. And in fact, yeah, we can also say that the arrays are maybe not, yeah, I would say the arrays are also the collections, but I would say maybe a little bit specific collections. Maybe not specific, but maybe more simple collections than the other collection types we have. So, and then let's talk about the collections as the part of the framework. So basically, yeah, collection framework exists in maybe not all the programming languages, but definitely in most popular programming languages it does exist. Yeah, so, and the framework, again, maybe we haven't talked about the term framework before. I mentioned it a lot, but so I'm not sure if all of you do understand what the framework term means in programming. It simply usually it means that this is the set of classes, files, basically the structure, the base structure, what we can use as a part of maybe we can use as the base or as the part of our solution. Yeah. And collection framework is the framework, the set of interfaces, implementations, and operations which can be used to deal with the collections I described in the previous slide. So, and yeah, the development framework class library also contains several generic interfaces, because some collections may be generic and some not. For example, let's say we have the collection array list. So the array list. You see this is not a generic collection. So my array list. So the implementation is simple, the same as basically all the arrays have, but it basically works dynamically with the array, so that I can add the elements. Here, element, I can add any elements once there. So no restrictions on the elements I add. And that's because, it's not generic, I do not provide a type, so it can accept all the types. Not generic. It's not generic. Generics inside can be added. So the advantages is don't need any type, and maybe we will talk about the structures of the collections during the next session. And today you'll have the test in 15 minutes, so I will talk about the structures of the collections later. So today I want to show the basics of usage, the basic usage of them. So we have my array list. So this is not generic. On the other hand, we have generic collections which use generic, and then this would be so we include generic collections, and then we can use generic collections. For example, we can use linked list. So, and here I can define the type of the elements it will store. So then I create the linked list, and then I say that list will only store these strings. It cannot store the integers. So for example, if I add integer, or if I add string, that will be correct. Let's say add last, that will be correct. If I try to add integer, that will not be correct, because as I said, the type here is string. So can't do it. If I define the linked list as the type integer, so create the object, then I can add the integer, and I can't add element list I. And then I can't add the string. And so that will be not possible. Won't be possible. So the type defined, the elements I can add, they cannot be different. Alright, and then maybe one question would be, can they be casted? And the answer is no, they cannot be casted. Because, maybe let's try to then, okay, upcasting does not work, let's try to use downcasting, and this should fail as well. This should only fail as well, because basically we have two classes which simply are not related using the inheritance. As I said, if for the generic types, we actually have one class defined, but it is used as two classes. Yeah, as two classes. Yeah, one class uses the strings, and another class uses the integers. Yeah, so the question from Elena is what are the differences between linked list and list? So yeah, that's a good question, and this would be the part of the structures. We will talk about next session. Yeah, I will explain what are the differences between the structural definitions of linked list and list. But for example, yeah, we can also read the descriptions. This is about basically from the usage point of view, they should be the same. I mean, you have all the same functionality. The generics are used there. You can add the elements, you can fetch the element, you can delete the element. So basically, the functionality for linked list and list should be the same. The difference is about the way how these lists are implemented, because again these are the objects, and you see we have array list, we have linked list, we have list, and the difference is about how they are implemented, because we know how the arrays are implemented. Yeah, arrays are created, they have the fixed number of the elements, we cannot increase this number of the elements, we cannot reduce it. Yeah, so once the array is created, we cannot change the size of it after that. Yeah, so it is fixed and it can't be changed. Yeah, so we know this implementation. The array lists. Array lists are created, so basically they are the objects. Yeah, so again all the collections are the objects. So this object will store the elements inside the arrays. This is why it's called array list. The difference is that every time you add a new element or you remove the element from the array list, every time it creates a new array. So technically you can implement it yourself. You can create a new array, increase the number of the elements. Then if you want to delete the element, you will create again a new array. So every time when the number of the elements is changed, then it creates a new array. Yeah, so this is what is the array list about. Linked list works in a different way. So I will again show you next time. But for my group, I explained that during the previous courses that the linked list is created in the way that for each element inside the linked list there is the pointer to the next. Again, it can be, see here it represents a double linked list. So it means that simply let's say that you want to link, let's say maybe 10 people. Yeah, so let's say you have 10 people and you want to actually implement some kind of collection of them. Yeah, so you can implement them as the array. That would mean that you have 10 positions. You place each person at each position. So that would be, they will be stored inside the array. Yeah. So, but let's say you want to collect, link, 10 people, basically a collection of 10 people using the linkage, double linkage. So what this would mean? This means that you have these 10 persons, and each person has the linkage to the next person, and also the previous one. That's why it's called double link. So it means that, like, let's say we have the row of 10 people, and then I am the person inside this list, and I have the link to the next person, and I have also the link to my previous person, that's me. Yeah, and I have the link to them. So it means that I know who is standing ahead of me and who is behind me. Yeah, so I know the information about these two. not the information, but I have the linkage. So simply means that I stored the reference to them. This is the linked list. Yeah, and the lists itself, strongly typed list of objects that can be accessed by index. So if I'm not mistaken, the lists are implemented in the way that they are also stored as the arrays. So it basically means that will be the same as the array, but using generic type. But maybe it's not applied to you. Maybe I will explore it before. I will check it before the next session because I forgot about the implementation of the list. But for the linked list, yeah, I'm sure that it is implemented in the way I described. Means that each element of the list, it has the link to the reference, the link to the next element and to the previous element. And basically each element has the link to the previous element, the next element. So basically using these links, we built the collection. So we don't have the array which stores these elements. We don't have any other structure. We only have the situation when each element has the link to the next element and also to the previous element. And then when each element do have this information, we build the list there. One moment, let me quickly check because I just notified you about the list. Yeah, for the linked list I'm sure, but for the list, one moment. Way of storage. Yeah, that's correct. So maybe I will also put the screenshot here because so maybe I'll put the screenshot. The list equals generic equivalent of array list class. Yeah. This is what I thought. Yes, so maybe let me. So this is what I said. I was right here, and that said list is the same as the array list, but it is generic implementation. Yeah. So yeah, this is what I thought, and yeah, this actually makes sense. Here, and then the idea is simple, as I just said. The objects are stored. The elements of this list are stored inside the arrays. Yeah, so it means that there's basically this is something similar to what we have here. We have the array, it stores the element, and basically now we have the collection my class, which stores the element inside my array. My array. Yeah. So yeah, it simply means that the elements are stored inside the array. For list, it is the same. Yeah, for array list is also the same, but for linked list there is no array. The elements are linked with each other, simply using the reference. Okay, so is it more clear? We'll talk about the types of these collections, about more technical details of them during the next session maybe. Yeah, so today is just such kind of introduction. But is it clear, Elena, or maybe more explanation? Well, maybe it's clear. Yeah. So we'll go through the technical details maybe next time. But so just for introduction, basically, the simple answer will be that it will be the same as the array list, but using the generics. Yeah. Okay, so then it is fine, and we can go next. And then they should be used whenever possible in place. Yeah, non-generic classes, they are maybe not really popular, and maybe this is maybe a little bit confusing because in C# array list is non-generic. In other languages, for example in Java, it is generic. So this may be a little bit confusing if you switch between the languages as I do. But yeah, so in C# instead of array list, we then better use list. And just because it is generic, so generic types are more safe. They are more structured. and they are, say, make more sense. Yeah, like, because again, in non-generic lists we can put everything we want. In generic lists we have these restrictions. Then okay, so then we can move on, and so yeah, so here you can see main interfaces used for the collection. Again, each interface has its own goal, has its own task, and yeah, today we used Innumerable Interface, which is used to implement the iterator. Yeah, so we can implement the iterator using it. I compares two objects. Then iCollection itself, yeah, defines size, enumerator, and synchronizer methods for all these collections. So basically, let's check iCollection class. iCollection. So iCollection, it if I go to iCollection, you see it already implements, not implements, yeah, it already extends IEnumerable. So it means that if I declare that my class is iCollection, I don't need IEnumerable anymore. No? So because, again, as I said, the interfaces can also extend other interfaces. Yeah. So this is possible, and in this particular case, if the class implements iCollection, then it can then it already implements IEnumerable. I don't need it. I don't need to define it separately then. Yeah. So then there are also other interfaces like read-only collection, means that I cannot change it if I'm not mistaken. We'll discuss it the next time. And yeah, other interfaces we'll maybe take a closer look later. But yeah, so let's maybe start today and then finish on Wednesday. Is about the operators. Yeah, so we already know what are the operations we can do. So for enumerator, we know that we can iterate. So this is one operation we can do. We can access the elements by index. So this is also another operation to do for indexers. We can add the element to the collection. We can add the element that corresponds at the position we provide. So let's say I want to add the element at position 10 maybe inside the collection, or I want to add the element at last position or at first position. And it can be possible. I can remove the element from the collection. I can remove the element, the last element. I can remove the element. I can remove the element at the position, or I can also remove the elements I provide. So let's say I want to remove the element 10 from the collection, and I don't care at which position is it located. I just simply want to remove it from the collection. Yeah. So that will be the option. And yeah, check if the object exists in the collection. So I can simply say, is there elements 10 inside the collection? Or like if you have strings, is there the string ABCD inside the collection? Yeah, so I can check and it will say true or false if the element exists in the collection or not. I can retrieve the element from the collection based on the index. Yeah, I can get it, or again, get first, get last. Remove, iterate through. Yeah, so these are the operations what we can do on the collections. Yeah. And of course, these all methods are implemented using these all operations are implemented using the methods. And so, yeah, for the collections, there are we normally do not overwrite the operators, generic operators, because I mean everything is based on the methods. and they provide us more flexibility there. And so you see that all the elements, all the actions we do, like add last, or I can also say add before. So I add before. So this is again the method, and so then I can yeah, I can add the node. Yeah, that biggest. No, hold on. One moment. That would be get. Or maybe, hold on, no. I can say add before 32, because that would be correct. And let's say the value 10. Will this be correct? No, one moment. Oh, okay, I need to provide node here. And the node, okay, maybe about that before I will explain it next time. So I need to double check that. Yeah, that would be maybe a little bit more specific about the nodes. But yeah, so basically all the main actions I do here, if I want to add or I want to clear or I want to find, so all these actions are done using the methods. Yeah. So I have the methods, I call them, and I get the result I want. So everything is based on methods. All right. So do you have any questions?
Yeah, hello.
Yeah.
I have a very general question regarding collections
Yeah.
as such. Do I understood correctly that collections is like umbrella term, and beneath it is all kind of collection types like
Yeah.
linked list,
Yeah.
list, array, so
Yes,
something like
yes,
that.
Irina, this is absolutely correct. So there is no such type as collection. Yeah, there is no such type
Okay.
as collection. It is the generic, yeah, let's say it is the interface. Yeah, basically it is the interface I collection, yeah, shown here. And as you know, the interface, yeah, I collection, it is the interface. And as you know, the interfaces are not, they are not types, they are the interfaces which then should be implemented inside the classes. Yeah, so basically it means that it is the interface which then needs to be implemented in the real classes. Yeah. Yeah, that's correct. That's a really good question, Irina, and this is correct. There is no such type like collection. Yeah, it should be,
Mhm. Thank you.
it should be something real, something specific. Yeah, because again, there are different types of implementations for the collections. We just talked about linked list and array lists, but linked lists, lists, array lists, so they are implemented differently. There are also the queues. Yeah, so you know how the queues works. Like there may be different way how the elements there are added or fetched from them, so it can be different. Also, yeah, again, the way of storage, how they are stored, how they are changed, how the elements are fetched, how the elements are inserted. So all these things can be implemented differently for different collection types. So yeah, well, maybe most will talk next time about them in more details about the differences between them. Um,
Thank you.
so any other questions? Yeah, questions?
I have other question not related with presentation. I have a question. In activity 6, we are supposed to create our own unit test. Yes,
Oh, yeah,
and
yeah,
I wanted to ask because I think in previous studies we haven't done it, most of us. So
yeah.
maybe is it possible that you show a small example? Of course, the
Mm,
possible to show not today, but like in
yeah.
general. Yeah.
Uh, basically, you can take a look on the unit tests you already had in the previous activities. So a moment, let me.
We did that, yeah.
So you
But
can.
still, feeling that something is missing.
Well, that's fine. Yeah, I guess that will be the nice topic. We can start next session. A moment. Yeah, that will be a nice topic. What we can start. Next session, we can take a look on the unit tests, how to create them, how to use them. Yeah, but
Thank you.
before that, of course, you can take a look on what we already used, what we already had. Yeah, so yeah, some using classes needs to be then kept as they are. So then there are some tags you need to use. So what each method, what does it do? Yeah, maybe this was not the best example from the activity 5, but yeah, maybe let's say activity 4. Yeah, so basically the tags, the markers for the methods, for the classes, what they do. And yeah, first if you want to implement some kind of testing logic, you need to define it as test. And there are some other parameters, maybe we'll talk, yeah, I guess that will be a large topic, what we then better do, discuss next time. But yeah, so this is a really nice topic, what we can discuss next time, yeah. But yeah, first we take a look on the examples and you can take some ideas from there already if you want, yeah, if not, then we can discuss it next time.
Thank you.
Yeah, so any other questions? Okay, then let me push the code from today to GitHub first. So yeah, I'll push the code now. As usual, put else, put commits. And push. Yeah. Okay. So and I'm sharing the tests now with you. So yeah. Also, let me show the presentation. Today's presentation. Okay, it's not finished yet. But okay. I think I can share it. No, why not? One moment. Let me show the presentation from today. So it is activities 4. Oh, sorry, that's not correct. Incorrect section. So it should be not the resources, yeah. I usually put it there. Okay. And yeah, so now I can share the knowledge check with you. Okay. So yeah, the idea would be the same. No hurry. Do it your tempo, and then you can, once you're done, you can send your answers. Okay, do you have any questions?
The deadline is as
Yeah,
previous time,
the
like
same as
yeah.
before. Yeah, the same as before. Yeah, no hurry for you. Yeah. Okay. Okay, then let's do the same way as we did the last time. So we can then close our video session, and I'm still in Discord. You can ask me any questions you want. Okay, if there is anything unclear. And yeah, so then please proceed. And then we can close the session and then move to Discord if any questions you have. Okay, so then I'm closing the session and wish you good luck in the test then. Okay, so now I'm closing, and please then proceed with.
Yeah, bye bye.
Yeah, please proceed with the task.